Hello students, in this video you are going to learn about some applications of mole concept according to the question which contains the greatest number of molecules. This is a straightforward question from mole concept. We are provided with four options. Option A 1 gram of carbon dioxide, option B 1 gram of dinitrogen, option C 1 gram of dihydrogen, option D 1 gram of methane. Okay, so we have to find which of these option has more number of or greatest number of molecules. The straightforward formula for finding the number of molecule is number of molecules equals to number of moles times Avogadro constant. So N represents number of moles and Na represents Avogadro constant, which is 6.022 into 10 power 23. Now let's find the number of moles for each cases. Before finding that, we need to know the formula for mole. Number of moles equals to mass by or given mass by molar mass. For the first case, the molar mass of carbon dioxide is 44 gram per mole. How I find this value? Listen carefully. For carbon, it is the value of atomic mass is 12. For higher oxygen, the value of atomic mass is 16. Since we have one carbon and two oxygen, which is equals to 12 equals to 32. Therefore, the value of atomic or molar mass of carbon dioxide is 44 gram per mole. Similarly, the molar mass of dinitrogen is going to be 28 gram per mole. For dinitrogen, it is 28 gram per mole. For dihydrogen, it is 2 gram per mole. For methane, it is 16 gram per mole. Now look at these equations. Since the mass for all these four, carbon dioxide, dinitrogen, oxygen, that is hydrogen, and methane are same, therefore the numerator value is always 1 for in all the cases, whereas the lower denominator value will lead to more number of moles. I repeat, look at the denominator. As the denominator is lower, the the number of moles will be very high. So among these options, we have high dihydrogen value is 2. Therefore, it is roughly equals to 0.5 moles. If you substitute for carbon dioxide, it becomes less than 0.5 mole. Again, if substitute for dinitrogen, again it becomes less than 0.5 mole. Similarly for methane. So therefore the hydrogen has lowest molar mass among the given mass, which is equal to highest mole. In terms of mole, the value of dinitrogen is highest among the given options. So if you substitute the number of moles N value in this equation, you would get roughly around 0.5 times 6.022 into 10 power 23, which is roughly equal to 3.011 into 10 power 23 molecules of hydrogen, dihydrogen. Similarly, we can calculate the number of molecules for the given options. But anyway, the question is to find the greatest value or greatest number of molecules, so that we have to find. Hope you understand. Let me summarize what we learned. First, look at the question, which contains highest number of or the greatest number of molecules. Step number 1, we have to do find the formula. Number of molecules equal to product of number of moles times Avogadro constant. We know that number of moles can be expressed as a mass by or given mass by molar mass of the compound, and the Avogadro constant is equals to 6.022 in 10 power 23. Now, in order to calculate mole, number of moles, we need molar mass. For that, we have to take atomic mass of or atomic mass unit of individual atom present in a molecule. Suppose, for example, in a carbon dioxide molecule, there are two types of atoms are present, namely carbon and oxygen. How many carbon? 1 carbon. What is atomic mass unit of carbon? It is 12. So 12 into 1, 12. Again, how many oxygens are present? 2 oxygens are present. Therefore, 16 into 2 equals to 32. When you sum these two values, you get 44 gram per mole. This is the molar mass of carbon dioxide. Similarly, we can find the molar mass of dinitrogen, which is equal to 28 gram per mole, and also for dihydrogen, which is equal to 2 gram per mole, and also for methane, that is equals to 16 gram per mole. Now we have successfully calculated the molar masses of given compounds. The next thing is we have to substitute the value of molar mass, because mass given in all the cases that equals to 1, whereas molar masses changes for different options or different given compound. So the lowest value of the denominator will get the highest number of moles. It is very simple basic mathematics. Therefore, among the given options, the dihydrogen has 2 gram, so the 2 gram per mole. When you substitute the value, it becomes 0.5. If you substitute for carbon dioxide, 1/44, definitely always or definitely less than 0.5 mole. If you substitute by 1/28 in the case of dinitrogen, it is always going to be less than 0.5. Similarly, we can calculate other given compounds. But now our focus is to find the greatest number of molecules in given the option. Therefore, when you substitute the number of moles times the Avogadro constant, you will get the nearest perfect value of number of molecules present in a given compound. Therefore, in the hydrogen or dihydrogen, we have roughly around 3.011 in 10 power 23 molecules are present. So the option 2, option 3 is always correct when you compare other options. Thank you very much.